Video, I want to talk about converting between logarithmic and exponential equations. So you guys are already familiar with regular exponential equations. So I'm going to give you a really simple example. A very simple example is 3 squared equals 9. Now, a logarithm is just the inverse function of an exponential function. So a logarithm is the inverse of an exponential function. Now, you might be asking, well, why do we need the inverse, or why do we care about the inverse of an exponential function? And that's because, so if I told you, remember in an exponential function, we have an output. So say we have an exponential function like 3 to the x equals, well, let's say it in the other way, f of x equals 3 to the x. So if I wanted to do the inverse of that, so it's easy to find points in this equation, right? You have like x, y, if x is 1, y is 3, if x is 2, y is 9, if x is 3, y is 27. But when I go to take the inverse of this function, remember then we are looking at the outputs and we want to find the inputs, so we're looking at it in reverse. So if I asked you what is f inverse, if I asked you what is f inverse of x, and say I wanted to know like what is f inverse of 9, well that would be easy, right? If the output is 9, the input is 2, so in the inverse function, if the input is 9, the output is 2, right? And what if I asked you f inverse of 27, well it would be 3, right? But what if I asked you what is f inverse of 20? Something between 2 and 3, right? It's between these two, but we don't really know what it is. So the logarithm is an attempt to answer that question, or it is the solution to that. A logarithmic equation is the inverse function of an exponential function. So that's what the logarithm is about. That's why we use logarithms, and logarithms allow us to find the exact answer of this. So the exact answer of this would be based on a logarithm. So let's go back now and take our very simple exponential equation and try to find a logarithmic equation that's the same as that. So this exponential equation, remember that it is one special case of this exponential function. This is one single exponential equation. So in a logarithmic equation, we're doing the opposite. So in the logarithmic equation, we're going to take the logarithm, which we usually write log. So we have log, and then the logarithm is going to have a base, but I'm going to leave that empty for now. And then we're going to take in the output. So we're going to take in the 9. So log of 9. And then we're going to put out the input, which in this case is the x, or the exponent. So log base something of 9 equals 2. Now, every logarithm has a base, and it's just like every exponent has a base. So this exponential equation this exponent has a base. The base is 3, the exponent is x. In this case, the base is 3, the exponent is 2. So the logarithm shares its base with the exponential function. So it's going to be log base 3. So the logarithm shares its base with the exponential function. That's important to know. So the logarithm shares its base, so the base is the same as the base over here, and then the input of the logarithm is the same as the output of the exponential function. And then it's equal to the exponent because that's the input of the exponential function. And it's also important to remember that, so log base 3 of 9 equals 2. 2 is the exponent, and all logarithms are an exponent. The logarithm is the exponent. So that's important to remember too. The logarithm is the exponent. And later on, when we talk about the laws of logarithms so that you can learn how to solve logarithmic equations, it's going to be important to remember that the logarithm is the exponent. This should just say exponent, not exponents. Okay, so if we want to convert a logarithmic equation or an exponential equation to a logarithmic equation, we keep the base the same. The exponent is what the logarithm is equal to, and the input of the logarithm is the output of the exponential equation. Okay, let's try one more example. So I am going to erase, whoops, not that. I don't know why I can't do this. Okay, now I'm going to erase that, and then I'm going to do one more example. So if we have an exponential equation, 4 to the x equals 12, how would we translate that into a logarithmic equation? So let's start by writing log. Okay, every log has a base, and the base is the same as the exponent, or as the exponential equation's base. So 4 is the base in this case, so log base 4 is equal to 12. So the output of the exponential equation is equal to the input of the logarithm. So the 12 goes here, and then it's equal to the exponent. So log base 4 of 12 equals x. Okay, I actually want to try one more. So what if we had e to the third equals y? How could we change that into a logarithmic equation? So log is something that always has a base, right? So we have log base, the base is the same, so log base e of the output, so of y, equals the input of the exponential function, which in this case is 3, or the exponent, always equal to the exponent. Okay, so this log base e of y equals 3. This is completely correct, but mathematicians are kind of, I don't know, they're weird and they're lazy, and because we use e in exponents so much, mathematicians decided to give log base e a special name. They called it natural log, which we abbreviate ln, which is like Latin for logarithm naturel or something like, or it's French, I think, maybe, for logarithm naturel. Anyway, but we would say ln of y equals 3. The important thing to remember is that natural log is the same as log base e, and if you ever get confused by natural log, you should always change it back to log base e, and that will probably help your confusion. So natural log, we write ln, and don't call it line, it's natural log, but ln of y equals 3 is the same thing as saying log base e. So if you ever get confused, just go back to log base e. Also, if you ever see a log that's just log of 5 equals x, if there's no subscript here, it's assumed that we're talking about log base 10. So this is equivalent to log base 10. So if there's no base written, then it's log base 10 of 5 equals x. So if you ever see this, just go ahead and write in the 10, and that will help any confusion that you might have. And that is how you convert between logarithmic and exponential equations.